Okay, I know the way that I've broken this up and adding these two topic 10 topics to the two topic 6 topics may seem strange, but it's because they're all very related. Let's take some notes for 10.1. Please title it the square root function. Okay. For example 1, I'm going to give you a function that's just simply the square root of x. And let's make a table of values for that. Remember, you're in total control of the x. We've been picking -2, -1, 0, 1, and 2, but notice we're taking the square root. Can you take the square root of a negative? No. So it makes no sense. Matter of fact, the domain of this function will not include the negatives. Now, can you take the square root of 0? Yes, you can. The square root of 0 is 0. How about 1? Well, the square root of 1 is 1. Now, I can use the calculator and do 2, but since I'm in control over the x's, let me pick things that I can take the square root of mentally, like 4 and 9 and 16. The square root of 4 is 2, the square root of 9 is 3, and the square root of 16 is 4. Notice I have all positive values. In this case, my domain and range are going to be positive numbers. So when I graph it, I really only need this first quadrant over here. By the nature of what I picked, I needed to go out to 16. Okay. And my y values, I only need to go up to 4. Graph those 5 points, 0, 0, 1, 1, 4, 2, 9, 1, 2, 3, 4, 5, 6, 7, 8, and then that's a 3, and then the 16 is a 4. Notice it's going to be a curve. Almost kind of feels like a halfway sideways parabola. Now, let's look at that. Let's think about what the domain and the range are. Remember, domain is the x values, and there's a definite limitation on the x. Remember, I could not take the square root of any of those negative numbers. So my x is going to be from the 0 on. So the domain is x is greater than or equal to 0. What about the y values? Well, I'm going to always get from 0 up. That's y is greater than or equal to 0 as well. Now I'm going to pull out the graphing calculator. You don't really need yours. This is just definitely for demonstration purposes. I know some of you were having dimension errors. Hopefully you cleared that out by turning off your stat plot, clearing out your lists, and then selecting a standard viewing window. I'm going to go to the y equals, and I'm going to do the square root. Remember that second, and then the square button right here. So the square root of x. And I am going to go ahead and close the parentheses. Now, to graph that, I want to make sure that I have a standard viewing window. You could have hit graph, but by getting the zoom standard, I'm going to have something that's fairly easy to look at. And we did a pretty good job. I could definitely adjust the viewing window, maybe doing maybe zoom integer. Let's see how that one looks. Yeah, it's okay. Or I can make our viewing window exactly what we have here, which is where I have the x's from 0 to at least 16. I'll go by 20s. And then the y's from, I have 0 to 4 at least. Let's go by 5s. Notice I changed the scales to 1s because I want to count by 1s. Now I have a graph that looks even more like the one we just did. Okay, now what happens to this graph if I manipulate the equation? Let me go back to a zoom standard just so that it's easier to look at. In the second y, I'm going to take the same equation and I'm going to put a negative in front of it. keeping the square root of x. Now, what do you think is going to happen? What's been happening to our absolute values in our parabola graphs? Hopefully you said flip, and it did. This is not a parabola, these are two separate graphs. Okay, now what if I took that square root of, oops, I lost it. What if I took that square root of x and down here I add 2 to the whole function? Think about what's going to happen. What happened to the parabola? What happened to the absolute value? Let's see if you're right. Did you say move up 2? If you did, you are correct. So I think you can guess that if I change this to a -4, it's going to move down 4. Let's see. And it did. Okay, now when we have done parabolas and we have done absolute values, when we manipulated the actual x in the function, remember that moved it right or left. So let me change this to an x minus 4 under the radical sign. Now, think about what that's going to do. Remember what happened with the sign? Let's see if you're right. Did you say left 4 or right 4? Hopefully you said right. Okay. The value that's in the radical with the actual x is kind of reversed. So if I would do a +3, it's not going to move right, it's going to move left. Let's see that. Okay, so again, nothing real new there. Let's see if you can make some guesses on a couple of examples as to what is going to happen. I'm going to take my f of x, and I'm going to give you 10 plus radical x, and I'm going to also give you the radical x plus 10. How are these going to compare to the parent function, which is radical x? Pause the video while you think about that. Okay, for the first one, remember 10 plus or a plus 10 is the same thing, and you are going to take this entire function and move it up 10. In this case, this is actually under the radical. You're affecting the x before you do anything to it. It's kind of reversed. The plus 10 is going to move left 10. So most of your homework involves problems like that. There are some where it wants you to do the average rate of change. And they'll give you a function. We'll just stick to our radical x. And then they're going to give you an interval. You might see it written in words, like from x equals 0.3 to x equals 0.6, or you might actually see it written as an inequality. It's the same thing. So it's actually asking in this graph, what's happening right here, this little tiny piece? What's the slope? What's the rate of change? Well, in order to answer that, you need to evaluate the function at both of these places. You need to know what the function is at 0.3 and what the function is at 0.6. Remember, that's just plugging in that value for x. So the square root of 0.3 and the square root of 0.6. So we'll grab our trusty calculator and figure out the square root of 0.3, and we'll figure out the square root of 0.6. I think the nearest hundredth is fine. This one is 0.55 and this one is 0.77. Now, the rate of change, remember, that's just slope. So you're going to subtract the y's and subtract the x's. And you're going to have 0.22 over 0.3, which gives you a rate of change of about 0.73. Okay, let's do one more example kind of like that. For example 4, let's give a different function this time. Let's use radical 2x. For this function, I want you to evaluate it at 8, 10, and 12. Go ahead and pause the video while you do that and make sure you have your calculator to figure out the square roots. All right, for f of 8, you should have the square root of 2 times 8. The square root of 16 is 4. For f of 10, you have 2 times 10, which is 20. And the square root of 20 is about 4.47. And for 12, 2 times 12 is 24. The square root of 24 is about 4.898, so about 4.90. Now, using this information, calculate the rate of change between the interval from 8 to 10 and also from 10 to 12. Pause the video while you do this. Make sure you realize you're going to be doing subtractions like you did on number 3. Okay, so for the first interval, you're going to do 4.47 subtract 4, and it's 0.47, and that's for the 10 minus the 8. So this is going to give you a rate of change when you do the division of 0.235. All right. If you didn't understand that, now that you've seen that, maybe pause the video and figure out this one. Okay, the rate of change from 10 to 12, you're going to take your 4.90 and you're going to subtract your 4.47. And then your 12 minus 10. Do the division, and you have a rate of change of 0.215. So this interval has a slightly higher rate of change than this one. All right, replay any of this video that you need to before you begin the homework. Call me if you need any help.